Hi students, welcome to Click GCSE. Today I am going to solve one past paper for mechanics A level. This paper is from October-November 2023. Okay, so before starting the paper, please share this video and subscribe the channel so that you can get regular videos. Okay, so without wasting time, so let's start the questions, please. If you see, the first question is given like this: the block of mass of 15 kg slides down a line of a greatest slope of an inclined plane. The top of the plane is a vertical height of 1.6 meter above the level of bottom of plane. Okay, the speed of block at the top of plane is 2 meter per second and the speed of block at the bottom of plane is 4 meter per second. So find the work done against the resistance of motion of the block. Okay, before solving question, always try to draw the diagram or the figure. Okay, it will be like easier to understand. So if I try to take one line here, so it will look like this. Okay, right? So now if you see this, as per the question, we have a block here like this. Okay, and this block is moving down. You can see here, as per the question, what we have initial velocity, that is u, which is given 2 meter per second, correct? And the mass of object which is given, that is 15 kg, correct? Okay, now this is moving down right? And the final velocity just before reaching this ground, which is given, that is 4 meter per second, and this vertical height of this is given, which is 1.6 meter. So what is the question is all about? The question is find the work done against the resistance of the motion to the block. Okay, let's start. So how to solve this question? Listen carefully. All of us know that work done principle is the work done against the applied force minus work done against the resistive force or resistance, which is equal to change in mechanical energy. What energy? Mechanical energy. Try to understand please. What is mechanical energy? Obviously kinetic energy and potential energy, correct? So I can rewrite this equation again. So work done against applied force minus work done against resistance or resistive force. So I can write down the change in kinetic energy plus change in potential energy. Do you understand? See, the object is at at height, that is, which is given 1.6 meter. Definitely this object must possess kinetic energy plus potential energy. Yes or no? Got it what I'm trying to say? So definitely there will be some change in potential energy as well as kinetic energy. So as per the question, we don't have any applied force. It, what I can say is, it moves due to the natural like what I can say, the gravitational force, right? So I can write down here like this. So definitely that work done against the applied force definitely will be 0. Why? Because as there is no applied force, the block moves naturally due to gravity, so the work done against applied force is equal to 0, correct? So what is WR? Obviously work done against resistance we need to find out. Change in kinetic energy, the formula is, that is half mv square, half times m times obviously v u1, obviously the final velocity minus initial velocity. So I can write down that is v squared minus u squared plus change in potential energy. What is the formula? mgh, m times g times height. So final height, okay, minus initial height. Very simple. Okay, this will be the what? The initial height, and this will be what? Final height, obviously. So I can write down again. So minus WR is equal to, please put the value here, half times mass I think is given 15, V squared. So V is given 4 meter per second, that is 4 squared. Initial velocity is given 2 squared plus mg, again it is 15, g is 10 meter per second, correct? Because acceleration due to gravity, meter per second square. So it is times height. Obviously the initial height is given 1.6 and final height, obviously when this block will come down, the height will be 0, right? So I can write down it will be final height will be 0 and initial height is given 1.6 meter. So please write down. So work done against resistive force is equal to, so if when you put this value in calculator, please put it, check whether you're getting 90, and minus when you put this value in calculator, you will get 240. So I got negative work done is equal to, it will be negative 150. So both we have a negative sign, so work done against the resistance of motion, definitely it will be 150 joule, because we know that unit of the work done is equal to joule. This is the answer for the first question. Understood everyone clearly? Okay, again I'm saying, while watching the video, please subscribe the channel and please share it, so that we can get motivated to do more videos as well. Okay, and please do comment, so what past paper you want to like get solved, okay, so that we can upload that particular paper as well. Now moving to next question. If you see the next question here, see what is the question is all about. If you see the diagram shows the smooth ring R, you can see here it is the same string, right? It is a same string, it's not the individual what I can separate string, it is the same string is attached, and this angle is given, which is given 30 and 40, and A is a horizontal force of magnitude 2n. This force is applied, you can see here, against X on R. The ends of the string are attached to the fixed points A and B on the vertical wall. The part AR of the string makes an angle of 30 degree. You can see here, this angle is 30, this angle is 40. Okay, and this ring is in equilibrium, correct? So question is, find the tension in the string and find the value of M. See, those who are very new, like what is tension, I can tell you what is tension is all about. Try to understand this clearly. Whenever I can say, see, tension means what? Tension is a kind of force. Do you understand what I'm trying to say? So I can write down that what is tension? The force applied, okay, by the rope, or we can say string. Okay, the force applied by the rope or the string is normally we call it as a tension force, right? Always remember, this tension acts away from the point of observation. Point of observation. Do you understand? Point of, what does it mean I'm trying to say? Listen. So right now my point of observation is equal to R, correct? So definitely your tension will act away from R. Again I'm saying, as R is the point of observation, my tension will what? Act away from R, correct? And as we are having the same string, so tension force will be exactly same. If it was like different string, right? So it will be T1, T2, two different tensions would be applied. Got it, everyone? Again I'm saying, just make a note of someone else. For example, one string is held like tight, or we can say it's called taut, right? Definitely there will be some tension. Okay, if there is slack like this, the rope is like there is slack like this, that means there is no tension. Do you understand what I'm trying to say? So this might have tension, this slack rope, we don't have any tension like this. Okay, now how to solve this? Here we have to find the components. How to find the component? Listen carefully, I'm just trying to draw this here. Imagine, so not imagine like this, because here already R we have. So here we need to find out the horizontal components and vertical components. See, one force is applied horizontally, which is given 2 Newton. You can see here, correct? Yes. Now we have a straight line like this. Please check it. I mean, which is fixed, and this is the tension force, which is I am taking as a T, and same tension force is applied here. This is also I'm taking as a T as well. This angle is given 30 degree. So please find out the horizontal components, vertical components. All of us know, if I take this as a resultant force, right? So definitely the vertical force will be, this one will be T cos 30. Why? Because this angle and this angle will be exactly equal. So if this is 30 degree, this component will be T cos 30, right? And this horizontal component will be T sine 30. Did you understand everyone clearly? Check it, right? Okay, now again this angle we have 40 degree, correct? So definitely if I try to draw vertical like this, so this angle also will be 40 degree, and this component will be t cos 40 degree, right? Okay, again this component will be t sine 40 degree. Understood everyone clearly? Please check, right? Apart from that, there is one more force will be applied. How? Because this mass of this r, I think it is given, mass is given, right? So mass of the r is given mkg, is given mkg, right? Mass of the values, we need to find out the value of mkg. So definitely one more force will be applied, which is called mg. So I can write down m times g equal to 10 meter per second square, acceleration due to gravity. So I can write down 10m. Okay, so as this ring is in equilibrium, so we can find out the vertical components and horizontal components and make it equal. Okay, okay, let's start. So how do this? So if I say uh, what are the vertical components we have, right? So vertical components is, you can see here, t cos 30, you can see, right? And bottom what we have, t cos 30 and mg. So you can write down t cos 30 degree plus mg, which is equal to t cos 30. Got it? Yes. Now can I write this mg? Obviously 10 times m equal to 10m. Sorry, I'm writing this t cos 30 plus 10m, which is equal to t cos 30 degree. So I can write down 10m is equal to t cos 30 minus did I change? Yes, sorry, my bad. This is t cos 40, my bad. Okay, t cos 40. So t cos 30 minus t cos 40, right? And finally m I am getting, that is t cos 30 minus t cos 40 over 10. So we got one equation of m like this. Got it? Now we'll try to find out the horizontal component as well. So how to find the horizontal component? Let's check. So now can I say the horizontal component? So horizontal component will be like this. See, this is t sine 30 and t sine 40 at one side, and other side we have 2 Newton. So you can write down that is t times sine 30 plus t times sine 40, which is equal to 2 Newton. Take the common t here, so I got sine 30 plus sine 40 is equal to 2, right? So we can find out T, the tension, is equal to 2 over, that is sine 30 plus sine 40. So when you put this value in calculator, check everyone whether you are getting 1.75 Newton, because tension is a force, unit will be Newton. So you can say the tension we got 1.75 Newton. What is the question is all about? We need to find out value of the mass m. So already we have expression for m, simply put the value of t here, so we can get this answer. So I can write down here. So this one will be like this. So m is equal to, we have, that is t cos 30, right? So if I try to take common here, t cos 30 minus that is cos 40 over 10. So m is equal to t, we have 1.75 times cos 30 minus cos 40 over 10. So please put the value in calculator and check what you're getting. So you might get 0.0175 kg. So obviously mass is given in kg, it is written in kg, so your answer will be in kg as well. Okay, let's move to the third question. Okay, you can see here the third question is written in this way, that we have a block of mass which is given 10 kg, right? 10 kg is at rest, rough plane inclined at angle of 30, you can see here 30. A force of 120 Newton which is applied to the block at an angle of 20 degree above the line of greatest slope, right? There is a force resisting the motion of the block. So obviously resisting motion means the force should be applied in opposite direction, right? Okay, so this will be the force direction of the resistive force. So the work done is given 200 joule, okay, of work done against this force when block is moved distance of 5 meter up the plane from rest. Okay, so question is, find the speed of the block when it is moved a distance of 5 meter up plane from the rest. That is the question is all about. Okay, before doing this question, always remember, I'll write something else. Remember this one: whenever a resistive force is given, right, whenever the resistive force is given, remember it includes what? The friction, we can say friction, it includes resistance, right? So what I'm trying to say is, no need, right, to go for vertical components. Do you understand? No need to go for vertical components. Okay, again I'm saying, whenever a resistive force is given, as it includes the friction, resistance, so no need to go for vertical components. So basically we'll talk about horizontal components here, right? So how to do this? Let's start. So obviously as it is a mass of 10 kg, there is a force which is acting downwards like this, okay, which is equal to mg component, right? So m is given, I think 10 kg, so 10 times g is acceleration due to gravity, which is 10, so meter per second square. So obviously you're going to get this is 100 Newton. Got it? Yes. And your one more component which is like this, right? And this angle will be 30 degree, right? Yes, this angle will be 30 degree. So basically we don't bother about the vertical component, so we are taught we'll take care about the horizontal component, obviously. So see, if this angle is given, sorry, this force is given 120 Newton and this angle is given 20 degree. So if I try to find out the horizontal component right side, so obviously this will be 120 cos 20, right? Okay, and this, if I talk about one more, see, if this is the vertical component including 30, so definitely one more horizontal component will get, because if this is the resistive force mg 100 Newton, right, so this one will be 100 sine 30. Check, right? Okay, here the opposite side, what force is applied? So one more force is applied, which is known as frictional force is applied as well. Now how to solve this question? Let's start. So I can write down that work done against the resistive force is given 200 joule. Okay, what does it mean? That means I can write down that WR is given 200 joule, right? And what is the distance is given? 5 meter, right? Now you tell me, if I try to, all of us know the formula, right? Work done against force, particular force, that is equal to like force times distance. First we will try to find out what will be the resistive forces given. Okay, we need to find out. So work done equal to force time distance. So WR is given already, which is given 200 joule, and that is resistive force time distance is given 5. So if I try to frictional, sorry, force due to resistance, it will be 200 over 5, which is equal to 40 Newton. That means we got to know one more force which is applying backwards, which is 40 Newton. Force against resistance, right? Force due to resistance. So I can write down here, because I need to find out the speed, right? How to find the speed? So I can write down that is net force, right? Net force is equal to applied force minus resistance force. Okay, so net force means F equal to ma. So mass, we have the mass, right, 10. Acceleration we can find out, that is a. So applied force, that is 120 cos, see this is applied force, right? 120 horizontal component we talk about, 120 cos 20 minus resistance force, what is given, we got 40 Newton, okay, minus what other forces we have backwards, that is 100 sine 30 degree, right? So again 10a is equal to, okay, we need to find out the value of a, so try to move this 10 this side, so I'll get 120 cos 20 minus 40 Newton, that is the unit of this one, that is 100 sine 30 over 10. So we can say that is a equal to, please put the value in calculator, check, you might get 2.276 meter per second square. So we got the acceleration. Understood everyone clearly, right? So by applying this applied force minus resistive force, so we got the acceleration. So basically the question is we need to find out the speed of the block, right? So how to find it, we have to use the formula, okay? So let's make a space for this. So we need to find what the speed. So definitely initial speed is 0, u is 0, and we need to find out final speed, right? And acceleration we got, that is, sorry, that is we have 2.276 meter per second square. Okay, now what is distance, s is equal to 5 meter is given, right? How to find it? So all of us know the formula is v squared is equal to u squared plus 2as. This is the formula, right? So what is the final speed? We need to find out v squared, u is given 0 squared 2as, 2 times 2.276 times, that is 5 meter, right? So v is equal to, we can find out square root of, right? So when you put the value in calculator, check what you're getting, you might get 22.76. Take the square root, which is v is equal to, it will be 4.77 meter per second. So this is the answer for this question. Got it? So the speed will be 4.77 meter per second. Okay, so if you feel difficulty that in understanding, so please pause the video and go back and try to understand what I have written there. Okay, and do comment also if you find difficulty. So I will try to, for example, you need to like learn about tension for type of forces, I'll make a dedicated video for that also. Got it? Yes. So now moving to the next question, right? Next question says that a particle p of mass 0.2 kg lies at rest on a rough horizontal plane, and the horizontal force is given 1.2 Newton is applied to p. Given that p is in limiting equilibrium, right? Find the coefficient of friction between p and the plane. So let me draw the figure first. For example, we have a horizontal plane like this, right? And we have a particle p as per the question, right? And the force, applying force is given, applied force is given, horizontal force which is given 1.2 Newton, right? Okay, and if the object is present or the particle is present on this ground, so definitely one force which is applying downwards, which is mg, that is one more force, m is given 0.2 kg, right? And g we know 10 meter per second square, acceleration due to gravity, so definitely it will be 2 Newton. So mg we got, this is 2 Newton. Okay, and one more reaction force will be acting upwards, right, which is exactly opposite to the ground always, right? Imagine, remember always, if it is a inclined force, right, and it is object like this, okay, and reaction force is always 90 degree of perpendicular to the surface like this, but obviously here the surface is the ground, so reaction force will be exactly opposite to the ground. You can see here there is a difference, huh? Okay, so here, and as per the question, there is a frictional force also applied. Obviously it will be applied to the backwards, like opposite to 1.2 Newton. So I can write down, this is frictional force, this will be frictional force, right? And if you know the frictional force, the formula is equal to F equal to mu r. Mu is the friction coefficient and r is the reaction force, right? So see, first of all, you have to understand what is limiting equilibrium. Okay, limiting equilibrium means, I can say, it is a maximum value of frictional force. Maximum value of frictional force is reached. Okay, and the body, we can say the body is the point of moving, on the verge of moving, you can say, right? Body is about to move, right? So how can you find this? So before finding this coefficient, obviously frictional coefficient is a part of force, we'll try to find out the net force. Means write down, you can write down like this. So we can say net force, which is equal to, that is applied force minus resistive force. Okay, what is the net force? F equal to ma, we know this, is equal to applied force, means this one, 1.2 Newton, right? So 1.2 Newton minus what are the possible backward forces we have? So backward forces means that is Fr. Okay, resistive force we have. So ma is mass is given, this acceleration we can find out. So okay, here acceleration we can find out, but if you see the question properly, the body is at rest, right? That means your acceleration is equal to 0. Very simple. So instead of acceleration, I'll put 0 here. Do you understand, everyone, clearly? So it is 1.2 minus F of r. So 0 is equal to 1.2 minus frictional force. So I got Fr is equal to 1.2. Did you understand up to this? So frictional force we got 1.2. Got it? And all of us know that is mu r. Mu r is equal to 1.2 here. Question is we need to find the coefficient, right? We need to find this coefficient. Mu is a friction coefficient. How to find it? Find the r. So unless you put the value of r, we cannot find the value of mu, right? So how to find this? If you see this question properly, the vertical component, I'm talking about this, this particular figure. So vertical component means r equal to mg. Simple. So r equal to mg, right? So that means r equal to mg, we have 2 Newton. So r equal to 2 Newton. Very simple. So in place of r, we can put 2 here. So if I rewrite this, mu times 2, which is equal to 1.2. So mu is equal to 1.2 over 2, which is equal to 0.6. So definitely this answer for this coefficient of friction will be 0.6. Did you understand? Okay, so when you read the question properly, see, so many things is given here. Body is at rest, definitely acceleration will be 0. Limiting equilibrium, that means body is about to move, that means maximum, means the body has reached the maximum friction force, right? That is mu r. Okay, which is almost equal to mu r as well. So by practicing, you can understand that what approach you have to apply in the particular question. Okay, now moving to next part of this one. If you see the next part, given instead that the coefficient of friction between P and plane is 0.3. So we are not taking the previous what I can say friction coefficient. I'm not taking 0.6. We'll take this is 0.3, which is 0.3. Okay. Now let me draw this again, so I can take back also, but I'm drawing this again. See, this force is given 1.2 Newton. So the downward force, which is mg, which is given 0.2 times 10. So this one we got 2 Newton. The reaction force will exactly opposite the surface, right? And friction force, that is Fr, which is equal to mu r, right? Okay. F of Fr means like frictional force, and mu r, that is friction coefficient times resistive force. Okay. Now what is the question is given? We need to find out, okay, find the distance traveled by P in the third second of its motion. Third second of its motion. We'll try to understand the question. Now listen, this particle is moving, right? Okay, this particle is moving. 1 second please. Yes, imagine in this way, this particle is moving, correct? So we need to find out the acceleration here. Obviously, as the particle is moving and particle is accelerating as well, right? So it moves more in each second. Try to understand this. Imagine the body moves this much in 4 seconds, in 1 second. Got it? So as the particle object is accelerating, it will move more in 2 seconds. Are you getting it? Again, it will move more in third seconds. So what is the question is, so find the distance the travel by P in third second. That means I need to find out, okay, this is for first second, second one, right? And this is third second. So basically we need to find out the distance of this particular thing, right? So how to do this? Definitely I'll try to find out the total distance for 3 seconds, right? Then I'll find out the distance traveled by this 2 second. Then I will subtract this 2, so I'll get this one. This is the approach of solving this question. Before that, we need to find out the acceleration. How to find this? Again, same thing. Net force is equal to applied force, right? This is force applied minus frictional force or resistive force, whatever it is given. So M already we know, that is a 0.2 times A, and frictional force, applied force is given 1.2, and frictional force is given mu r, right? So it will be 0.2A, which is equal to 1.2, mu is given 0.3, and r equal to, this r equal to, what is that? Mg, 2 Newton. This is 2, simple. So 0.2A, which is equal to 1.2 minus, that will be 0.6, right? So A is equal to 1.2 minus 0.6 over 0.2. So A is equal to, check with the calculator, you will get 3 meter per second square. So we got acceleration is equal to 3 meter per second square. Everybody understood this clearly, right? Now we'll try to find out the distance for all these 3 seconds, the full distance, okay? Then we'll try to find distance for this 2 seconds traveled, okay? Then subtract this, then I'll get this, the third second of this motion. So let me get the space for this. Okay, so how do this? We'll get 3 sections, right? So first we'll try to find out the total distance. Total distance means it will be 0 to 3 seconds, correct? So how to find this? So we'll take the formula S equal to ut plus half at square, right? So distance S equal to, obviously initial velocity will be 0, right? That is 0 plus half at square, half times acceleration we got 3 meter per second square, and time also 3 seconds, that is 3 square. So I got S is equal to 13.5 meter. Check the total distance I'm talking about. The total distance, I got the total distance, that is 13.5. Got it? Okay. Now we'll try to find out the distance for this 2 seconds, right? So this will be 0 to 2 seconds, like this, right? So again I'll use the formula, that is S equal to ut plus half at square. So S equal to ut, so here initial velocity is equal to 0 plus half times A, acceleration is given t, and this will be 3 meter per second square, and time is 2 seconds, 0 to 2 seconds. So S is equal to, when you put the value in calculator, you'll get S equal to 6 meter. So we need to find the distance, this one, right? So the distance required, that is 13.5 meter minus 6 meter, which is equal to 7.5 meter. So this is the answer for this question. So this will be 7.5 meter. Okay, so in this part I have solved questions 1 to 4. In next part I'll be solving 5, 6 and 7, 3 questions left. So see you in the next video. Okay, till then please share and subscribe the video, so that the channel, okay, share the video and subscribe the channel, so that we can get motivated to upload more videos. And do comment in the comment section that what past paper you need. Basically I teach physics and maths, okay? So please do comment, so I will share the video, upload the video according to your need. Thank you and have a nice day.